that up. Forgot to record, sorry. Yes, we're talking linear functions, but this is a plane function. And the basic definition of an ordinary function is a relation in which each x-coordinate, is anybody feeling the urge to fill in the second half of this? Is paired. How many y-coordinates? One y-coordinate. In fact, it's such a big deal, they put in the word exactly. One y-coordinate. So you can have no more than one, no less than one. To be a function, each x-coordinate is paired with one y-coordinate. No more. And so we're going to look at functions in a whole bunch of different ways to write them. I'm going to start out with just a basic set of ordered pairs here. And I want you to tell me yes or no, is this a function? Is each x-coordinate paired with just one y-coordinate? 2 is paired with 7. Do you ever see an x-coordinate of 2 paired with something else? Nope. Okay, 3 is paired with -1. Do you ever see 3 as an x-coordinate anywhere else? Nope. So that's good. 4 is paired with 8. I don't see it paired somewhere else, or -9. So yeah, that's a function. Nice and simple. Let me try this one on you. Suppose I give you 4, 5, 6, -3, 7, -4, 4, 11, and -2, 1. Is that set of points going to form a function? Why?
Because of the 4 and the 11.
Yeah, I got people over here telling me we got 4, 5, we got 4, 11. That's x-coordinate of 4 is paired with 2 different y-coordinates. You can't have that happen. So nope, that is not a function. So kind of a big tip to that, your x-coordinate cannot repeat. Now this one sometimes causes debate. Suppose I gave you 8, -7, -3, -7, and 14, -7.
Yes, because that's just the y that's repeating, so that don't matter.
The y is repeating, they're right, it does not matter. All that matters is that x-coordinate doesn't repeat. These x-coordinates aren't repeating, it's good. Okay, with me so far?
Yeah.
Alright. There's a bazillion ways I can show you this type of situation. A set of coordinates is 1. Another way I can set this up for you is I can give you a table of values. So I'm going to give you a little table here. And we'll put x and y coordinates in it. And I'm going to put in -8, 0, 4, -3, 7, and 9. And then our y's are 2, 5, -3, 6, -8, and 2. And so I'm asking you now, looking at it in that form, can you tell me whether it's a function?
Yeah. Yeah.
Why?
Because
Your x's are repeating. So yeah, same thing, just a different way to list it. So yes, that one's a yes. I got one other one for you. Let me write that one too. Oops, I forgot. Oh, I didn't need to go there. You have to let me finish on this one. I'm setting a trap.
Oh, you are?
Mm-hmm.
Yes.
So now you all immediately said no because you saw what? You saw the x-coordinates repeat, but check out the y-coordinate. 3, oh, sorry, that's supposed to be a 9. Sorry, try that again. Yeah. Yes, it's repeating 3, but since it's 3 negative 9 both times, that's the same point, isn't it? So then it doesn't matter. So yes, that still works. Okay. Now, I think you'll remember this one from Algebra 1. Anybody remember doing a mapping?
No.
These little ovaly things?
Yep, I remember that.
Oh. It's not hard.
Yeah, those ones.
Okay. The first circle is your x-coordinates, the second circle is your y-coordinates. Okay?
I'm gonna say it's
And by my drawing an arrow from negative 2 to 5, I'm saying when x is negative 2, y is 5. And if I draw from 6 to negative 3, I'm just telling you 6, negative 3 is an ordered pair. And what if I draw 10 to 5?
10 is
Is that a function?
yes. No. Well, no. Yes. Yes.
Am I repeating any of my x-coordinates? No. Okay, what would I have to do to make it not be a function?
Put another negative 2 in there.
Yeah, okay, if I took negative 2 also over here to 3, if I had negative 2 going in 2 places,
Yeah.
now negative 2 is paired with 2 different y-coordinates, then it's a no once I switch on you. So your now my x-coordinate is repeating. Negative 2 is being used twice, so it doesn't work. Okay, now, does anybody remember the terminology, what we call, there's a name for the set of x-coordinates and a name for the set of y-coordinates. Actually, this is called the mapping, but that set of all x-coordinates are called starts with a D.
What's next letter?
Oh?
Dot.
Domain, yes, woo! Oops, I just killed the microphone. Don't get so excited about domain. Okay. So yes, that's the domain. Anybody now remember what the Y's were? Range, yes. So domain is all the x-coordinates you can use in a function. A range is all the y-coordinates that result from that function. So in this case, if I said to you, using this mapping over here, to write me the domain, what x-coordinates are in the domain? Yeah, so you would list the domain as negative 2, 6, and 10, and you would list the range as what?
Negative 3, 5.
Yeah, it's that simple. So far. This part I hope seems pretty easy. This is the first page of the book problems. You're doing lots of yes and no, is it a function, not a function, name a domain and range, that kind of stuff. Okay, now, the final way I can present this to you is I could give you a graph. If I give you a graph and ask you, is it a function? Do you remember how you could tell whether, remember, every x-coordinate is paired with only one y, so your x's can't repeat. Do you remember how you could tell that looking at a graph?
Oh, we could get it if it didn't like loop back. Like if it didn't cross the same
It's 2 points.
Okay, remember, x-coordinates are down here, so like if I choose 1, okay, at 1, this graph has a y-coordinate up here, whatever number that is.
it didn't go straight up or down.
Yes. Do you remember, you might have called it the vertical line test?
Vertical line test? Yes.
Or one of the junior high, somebody teaches it as the pencil test, and they would roll their pencil across it. Okay. So if you can put your pencil across and always hit 1 point, it's a function. Or if you can draw vertical lines and you always hit 1 point, it's a function. Let me show you. Okay, let me show you one that crashes and burns. Suppose I did something like that. Because now if I draw a vertical line, I hit it 1, 2, 3 times. So I would have, it's got 3 different y coordinates. That is a no. So as long as you can only hit 1 point, always hit 1 point, it's a function. If you can draw a vertical line and hit more than 1 point, it's not a function. I just crashed and burned my mic again. So, do I need to show you another one of those? We seemed a little dicey on that. We're actually going to be in a really great spot. What would be something that will cause you issue? Do you know what it means when I leave an open circle? Okay. What this means is this graph is solid till right there, and then there's no point right there, because I left an open circle. But there is a point right down here. Okay, so is this going to pass the vertical line test? Yes. Yeah, because I hit 1 point. I hit 1 point. If I draw right there, am I hitting 2 points? No, because that one's open. Now, if I close that one in, if I make both of them solid, then it's not a function, because then I am hitting 2 points. But as long as I leave that open, then yes, that works. Okay, so that's an excellent place for us to stop, because then we can come back and talk about function notation.